In this video, we're going to graph some graphs of the tangent function. Um, it has some differences to the sine and cosine functions that we graphed earlier. So I have the characteristic points available for you up here, that its period starts at negative pi over 2 and goes to pi over 2. So that means that it has a period of pi. It has vertical asymptotes every pi units at the odd multiples of pi over 2. Um, at the uh, multiples of pi, it's going to have zeros. And halfway in between there at the odd multiples of pi over 4, it's going to have these characteristic points that are going to match what we would normally think of as the amplitude, whatever that multiplier is that's out front. So normally at pi over 4, tangent has a value of 1. So whatever we multiply that 1 by, it's going to take on that value. At negative pi over 4, tangent usually has a value of negative 1. So it's going to be the opposite of whatever that multiplier would normally be whenever the inner part of the tangent function has a value of negative pi over 4. So there's our basic characteristic points for the tangent graph. We're just going to go ahead and graph these in Desmos. I'm not going to try and graph them by hand. You can use the transformation techniques that we learned earlier. You can graph characteristic points like we did earlier, whatever works for you. But usually we don't graph these by hand, because not very often, because of the asymptotes that are involved in tangent and cotangent and secant and cosecant, which are all in this unit. So we want to be able to clearly show that they approach asymptotes. There's our zeros at 0 and pi and 2 pi for this graph. It's a decreasing function. It still has its asymptotes at negative pi over 2 and pi over 2 because it shifted a whole period. So really, this plus pi didn't do anything because it's a period. It would be the same thing. Take a look as if I just got rid of this, and it's the same graph. So you didn't do anything because pi is the period of tangent and cotangent, that you shifted it so that the lines are right on top of one another. All right, let's look at the next one of 3 tan of 2x. This one has a horizontal compression, and so things happen twice as fast, meaning that the asymptotes are going to happen twice as often. The zeros are going to happen twice as often. So instead of the zeros being at 0 and then again at pi, the zeros are at 0 and then pi over 2. That puts the asymptote at odd multiples of pi over 4. And that puts my characteristic points that had the same value as the multiplier at pi over 8 and negative pi over 8. So if I wanted to see what that point was right there that had a y value of 3, it's hard to get it right there, but I'm going to give this a name, f of x, and I'm going to put the point on there, f of pi over 8, so that you can see it, that it's equal to 3. And if I want to graph this, it's not going to let me graph it, but let's put it right here, f of pi over 8. There you go. You see it? Look at these. Okay, let's go on to the next one down here, which is number 4. And that's going to be 2 tan of 1/4 x, which is going to be a horizontal dilation, a horizontal stretch, and it's got a vertical stretch as well. So not only are the asymptotes and zeros happening less often, they're 4 times the distance apart from each other as normal. So 4 times, normally they happen every pi, now they happen every 4 pi. My period has changed to 4 pi. My asymptotes are now halfway between 0 and 4 pi at 2 pi, negative 2 pi, and so on. My characteristic point that had the value of this multiplier here is halfway between that. So at pi, there's a value of 2 right there. So that's at 3.14, blah, blah, blah. You know, pi is right about there, has a value of 2, and negative pi has a value of negative 2. And you can see how the graph got stretched out. And not only in the horizontal direction, but in the vertical direction because of that multiplier of 2 as well, that things are growing twice as fast in the y direction. We've got 2 more to look at in this section with tangent. Here's the next one. Negative 4 tan of x minus pi over 4. So this one happens way more often, and it's got a shift of pi over 4 to the right. I'm sorry, it doesn't happen more often. I was just zoomed out. So here, let's get back in between negative pi over 2 and pi over 2. So its period has not changed because there's not a multiplier in front of the x, but there has been a phase shift. It's out of phase of the original by pi over 4. So you can see there's pi over 4, 0, 5 pi over 4, 9 pi over 4. So every pi still, but it's 4 pi over 4. With the first one starting at pi over 4, there's a 0. And then the asymptotes are going to be halfway in between these zeros. So it's at 3 pi over 4, which is in here, right? Right in there. And you can see it. The asymptote is down there and up there. And it has a multiplier of negative 4, which reflected it over the x-axis. And let's see, so we were at 3 pi over 4 just a second ago for the asymptote, which makes our characteristic point at 3 pi over 8. So that's right here. Right in there somewhere is 3 pi over 8 negative 4, and negative 3 pi over 8 positive. It's not going to, I'm sorry, it's not going to be odd function. It's going to reflect about this point. So your you've got your y-intercept right there at x equals 0, y equals 4, because tangent of negative pi over 4 is right there at the negative 1. Negative 1 times negative 4 is positive 4. So that's pretty nifty that it's got that characteristic point right there as the y-intercept. All right, this is our last. We got just a couple more. So we're going to get rid of that 4 in this one. And you can see how that changed the y values. It didn't change any of the x values, but it changed the y values and made them come back down to their normal y values, just reflected over the x-axis. So there you go. At pi over 2, we have our negative 1. And for our last one, we're going to get rid of that reflection over the x-axis. So we have 0, negative 1. pi over 4, 0, pi over 2, 1, and our asymptote is going to be at, what would that be, 3 pi over 4? Yeah, 3 pi over 4. And then you can see the pattern that continues there. So the asymptotes are 3 pi over 4, 7 pi over 4, 9 pi over 4, and so on. And our zeros are pi over 4, 5 pi over 4, 9 pi over 4. You get the pattern. All right, that is it for this video. We'll come back next time and we'll talk about some cotangent graphs.